our lab today, and we are going to be performing our experiment number 7, which is identifying a weak acid by the determination of its Ka. Okay, but before we start, I want to just remind you some of the safety rule we have in our lab. You need to have your safety goggle, okay, and your lab coat, plus the closed-toe shoes on, okay, anytime you are coming to lab, actually to perform lab, and make sure you have all those on all the time, okay. And now, before we move to the purpose, we'll talk to you about the purpose and then the procedure, okay, step by step, okay, procedure. I want to give you my name is, I am instructor Alado, okay, so just prepare the video to help you with the lab, okay, just like I said at the beginning. So the purpose of this lab, okay, of this experiment is to determine the acid, the association constant of an unknown sample, okay. You have the unknown sample here, okay. This is the unknown acid, So to do this, you will titrate the sample with a commercially prepared a strong base. Okay, we have our base here, 0.1 mole sodium hydroxide. Okay, we are going to use for the lab. Okay, so actually you need to perform 3 titration. Okay, this is what the book is recommending you to do. But your instructor will actually determine, okay, how many titration you have to actually perform in your lab. Okay, it can be 1 titration, can be 2, or it can be actually the 3 titration the book is mentioning here. Okay, so after you perform your titration, the next thing you will do is to draw a titration curve. You're gonna draw a titration curve of a pH. The pH should be on the y-axis, Vs volume of NaOH, at on the OX axis. Okay, for each titration you perform in this lab. Okay, so what is the reason of drawing a titration curve? The curve will actually allow you to determine the equivalence point, the half equivalence point, the pKa, and the acid the association constant of the unknown acid. Okay, now let's move to the procedure, okay, step by step. So this lab have 3 parts, okay, in the procedure. Part 1 is to prepare your unknown acid, okay, prepare your unknown acid. Part 2 is to prepare your pH meter. Actually, we have, this is the pH meter we are using, okay, in the lab. You should have one also to use, okay, during the lab. And part 3 is actually the titration. In part 3, you are going to perform what we call a titration. Now, to start your lab, look at the setup I have. Look at the setup I have, okay, in front of me. You need to make sure you have the same setup on your desk. Okay, you need a stand, okay, and the tube holder, the clamp here, okay, and you need 400 milliliter graduated 400 milliliter beaker, okay, and you might want to use 100 milliliter graduated cylinder, or you can use 50 milliliter graduated cylinder also, okay, for your your measurements, okay. You also need a phenolphthalein, okay, indicator, okay. This will tell you when you get to the equivalence point with the color change of your solution. Now, you make sure you have all those, okay, same setup, the tool you need. Now you can move to part one, okay, where you have to prepare the acid unknown, okay. Now, how you gonna do that? Your procedure is asking you to get 25 milliliter, okay, of acid, okay, of unknown acid. Okay, you get 25 milliliter of unknown acid. Is what we are going to do right away. 25 milliliter. Okay. When you are measuring your volume, make sure you read from the manuscript. Okay. Now I can do this because I'm used to, okay, to measure those solution in lab, but actually you can use, if you are not used to it, you can use a pipette, okay, actually to do that, to measure the volume, okay. You can use a pipette, okay. It will take a long, but you have to do it, okay, if you are not used. Because I'm used to this, I'm gonna pour this, okay. I'm gonna pour my 25 milliliter. So I have the, okay, wait, yeah, I got my 25 milliliter of acid, okay. I'm gonna pour it into the 400 milliliter, okay, of beaker. I have, okay, already set up for this experiment, okay. So I have my acid ready, okay, for the experiment. But in order to determine the equivalence point, or knowing when we get to the equivalence point in this experiment, you need the phenolphthalein, okay, which is a color indicator. So you need to add 5 drops, okay, 5 drops to the acid, okay. Make sure you shake the beaker to actually mix the acid and the phenolphthalein, okay. So that this is part one of the experiment. Now you move to part two. Part two is the preparation of the pH meter, okay. So in part two, they're asking you to calibrate your pH meter, okay. So you're gonna have, it's already done. Usually we make sure because you come to lab that those things are already calibrated, but you still have to double check, okay. You still have to double check to make sure your pH meter is calibrated, okay. So, and when you're done, you make sure your pH meter, the probe, is clean and ready, actually ready to perform the lab, okay. So I have my pH meter on the side, okay. It is ready for the lab. Now part three, part 3 is where you're going to perform the titration. But before you perform the titration, you already have your sodium your unknown acid, okay? Sorry, your unknown acid ready, okay? Now you need to fill up. You need to fill up the burette, okay? You need to fill up the burette with the base, the strong base you are going to use for the lab, okay? We are using a sodium hydroxide, 0.1 molar sodium hydroxide. So I'm going to fill the burette, okay? Before you fill the burette to the top, okay? You have to fill the burette to 0. Make sure you move your acid to the side, okay? And then you can fill the burette. Fill the burette to 0, okay? To adjust it to 0, I have to let drain some of the base out, okay? So, I have a step I already performed before we start this video. You have to make sure you clean your burette, okay? So in order to do that, you have to fill it up with the same base, with NaOH, and then drain it out, okay? Fill it to the top and drain it out. This is how you clean you make sure your burette is clean. And then you fill it up back with a new NaOH, okay? The one you clean the burette with, you need to dump it in the liquid waste, okay? Now I have my burette filled with NaOH and ready for the titration part, okay? Now for this titration, our goal is to draw a titration curve, okay? So each time you add 1 milliliter, okay, of base to the acid, okay, you have to determine the pH of the solution, okay? You have to determine the pH of the solution each time, okay? And by the end, you're gonna have a series of data that will actually help you to draw your calibration curve, okay? To draw your calibration curve, and then from there you can determine the pKa, okay, the volume of NaOH at equivalence, the Ka of your unknown acid, okay, and the half equivalence, okay? Those are what you need for the calculation part of this lab. Those are what you need to actually identify the acid. But now, if you look in the background parts, of your lab, we have here what we call your lab page book. We have what we call a master inventory list. The master inventory list will actually help you to identify which acid is the unknown acid. Okay. Now let's move to the titration part. Okay. Now for this part, you need to have a book note, something on the side, okay, to actually write down the value, your data. Okay. You actually need something, a book note, a book sheet, to actually write down the data, your data, the volume of base you are adding and the pH you are reading. Okay, so this is how you're gonna proceed. You're gonna perform this part. Okay, you're gonna add the base by increments of 1 milliliter. Okay, so this is what I'm gonna do now. Okay, okay, just have 1 milliliter, add to it. Okay, so after you drop 1 milliliter, you need to actually share, okay, the beaker, share the beaker, okay, shake it. Okay, why we are doing this? To get the whole uh, phenolphthalein, okay, and the acid mix up. Okay, we need to have a good mixture, good solution here. Okay, now after you share, you're gonna measure the pH of the solution. Okay, make sure you turn this on. Turn your pH meter on. Okay, and then you measure the pH. Okay, so the pH actually of my solution is 3.4. Okay, it's 3.4. So this is what you get. This is what you get when you add 1 milliliter of NaOH. So in your book note, you need to write down 1 milliliter. Okay, and then the pH corresponding to that 1 milliliter of NaOH should be 3.4. Okay, 3.4. Now, one thing I want to remind you is that even before we move to this step, you have to actually measure the pH of your initial solution. Okay, you measure the pH of your initial solution. Okay, before you move into or you start adding, okay, the NaOH by increments of 1, right? Okay. Do not forget that part. Measure the acid first. Okay, measure the initial acid, the 25 milliliter of acid you have in the beaker. You need to measure the pH of that first. Okay, before you start adding. Okay, now we're gonna move to add another increment. So now I add 2 milliliter. Okay, I add 2 milliliter. Now my pH jump from 3.4 to 3. I have 3.4, 3.5 before a jump to 3.8. Okay, 3.8. So now this is how you're gonna proceed. Okay, this is how you're gonna proceed until you get a color change. So each time you add, okay, you start with 0. You write down, you measure the pH of your initial solution, acid solution. Okay, and then each time you add an increment, the base NaOH by increments of 1. Okay, 1, 1, 1. So you should go from 0. Okay, the pH of the acid, you move to 1, you move to 2, 3, 4, 5. Okay, until you get to the equivalence. Okay, so that's what I'm gonna actually, okay, just to show you the step until you actually get to the equivalence. Okay, anytime you are doing, I want to show you the equivalence. Okay, so this is what I get. Okay, so as you're going by increments of 1, okay? Each time, measure the pH of the solution. And when you get to equivalence, okay, actually I'm getting my equivalence, I'm getting the color change at around 23, 24, okay? So you're gonna measure what happened at that time. When you measure the pH, when you get to equivalence point, you're gonna have a big jump in the pH, okay? You're gonna have a big jump in the pH. Make sure you have all your data written down, okay, on your notebook, okay, the data you are going to use to draw your graph. So this is equivalent. You can see that the color change, okay. So the volume at equivalence point is 20. That's what I get, okay. Probably yours might be slightly different from what I'm getting here, okay. So you don't have to question. This is a lab. This is an experiment you are running. Okay, we cannot get the same exact value. Everybody cannot, the lab cannot get the same exact value. So this is what I'm getting. You might get 23. You might get it at 20, depending on how accurate we are in this lab. So now, when you get to your equivalent point, you have your data written. You need to continue, okay? You need to continue again by increments of 1, because you need to get a plateau size of the graph. You know how the titration graph look like. You need to get now, where you are now, you can get the equivalent points, a half equivalent. Now you need the plateau size of the graph. So you need to continue to add, okay, by increments of 1, okay. And anytime you are adding it, for example, now the pH right now is, my pH is 10.8, okay, after my equivalence point. My first pH, the first pH I'm measuring is 10.8, okay. I'm going to add another increment of 1 milliliter, okay. So, and then make sure you share. Okay, so you have a pH of 10.9, okay, 10.9. Add another increment, 5. I measure, I have another measurement, 10, from 10.9, I move to 11. So you will notice that the change in your pH is not that wide, okay. It's not too big, right? The increment or the change in the pH is very small. So this is telling you that you are on the plateau size of your graph, okay. Now, after you get to the equivalence point, just keep actually dropping the NOH by increments of 1. You can do this like 5 to 6 times or to 10 times, or you can do it until you finish all the volume of NOH you have in your burette. It will depend on how what your instructor actually, how far your instructor actually asks you to go into doing this. Okay, so now you have all the data you need to actually draw your titration curve. So, and then you're gonna use your titration curve by the end to determine the half equivalence, the volume of NaOH at equivalence, okay? And you should be able to determine or to identify the unknown acids you use for the titration, okay? So when you're done, make sure you clean up, okay? Clean up meaning here, you have to dump, okay, your solution into the liquid waste. Make sure you wash, okay, wash everything, wash your beaker, okay, and make sure you wash the probe, okay, of your pH meter. Make sure you wash it. Okay. So you wash it, and then you dry. You wash it, you dry. Okay. And you put it back. Okay. Clean up around you. Okay. Put the stand, the clamp, the burette back. If you have any edge left in the burette, drain it out and clean the burette. Okay, make sure it's clean, and you should be good to go. Okay, so thank you for your attention.